The first thing we would like to find is the inverse of h. After we've found the inverse of h, we want to find h inverse's domain and range. Let's go ahead and start by finding h inverse. We're going to replace the y in the original equation with x, and then every x in the original equation with a y. Now we're going to solve the equation we've created for y. As soon as you see an equation with a fraction, your first thought should be to multiply both sides by the denominator. Multiplying the right side by the denominator, I can cancel the 3 plus 4y, leaving me with negative 7y plus 8. Distributing the x through on the left side, I get 3x plus 4xy. Early in algebra, you hear the saying, letters on one side, numbers on the other. But let's modify that statement to what you're looking for on one side, everything else on the other. In this one, we're looking for y, so we want all the terms with y on one side and all the terms without y on the other side. 4xy and negative 7y both have y in them, so we want them on the same side. And then 3x and 8 do not have y's in them, and we want those on the same side. We already have 4xy on the left, so let's move the negative 7y over by adding 7y. We already have 8 on the right, so let's move the 3x over by subtracting 3x. Using addition and subtraction, we've moved the terms with y on one side and the terms without y on the other. This allows us to take the y in common out front. Taking y out of 4xy, we're left with 4x, and y out of 7y, we're left with plus 7. I'm going to bring down the 8 minus 3x. The y is being multiplied by 4x plus 7. So to get rid of multiply by 4x plus 7, let's divide by 4x plus 7. We have found the inverse of h. So using a little better notation than y, I have h inverse of x is equal to 8 minus 3x over 4x plus 7. Now I'm just rewriting the functions h and h inverse so they're front and center. Let's find the domain of h inverse. We do not want to use a number that makes us divide by 0. So to find the number that makes us divide by 0, let's set our denominator not equal to 0 and solve. So subtract 7 and divide by 4, and we find out that our x cannot be negative 7 over 4. Writing this in interval notation, we can use every number except for negative 7 over 4. So negative infinity until I get to negative 7 over 4, parenthesis to leave it out, union, parenthesis to leave out the negative 7 over 4, pick back up right after that and go forever to the right through infinity. Keep in mind, we have swapped the x's and y's to find h inverse. Swapping x's and y's is really like swapping domains and ranges. So the domain of h inverse is the same as the range of the h function. If I want to find the range of h inverse, I could find the domain of h. So let's find the domain of h. We do not want to divide by 0, so let's find the number that makes us divide by 0 by setting the denominator not equal to 0. Subtract 3, divide by 4, so we should not use negative 3 over 4. The domain of h are all the numbers except for negative 3/4. So I've written this in interval notation to leave out negative 3/4. We've done this because the domain of h is the same thing as the range of H inverse. So finding the domain gives me the range of the other function. Here's just a quick graph of H and H inverse so you can verify visually the domain and range.